Good morning. I'm Kiran Kumar V, working as an assistant professor in Department of ISC. So today I'll be handling maximum and minimum problem. Now, what is a problem statement? A problem statement is you have got n number of elements, and in this n number of elements, you have to search which is the minimum, which is the maximum. Okay. Now, using the straightforward technique, what you're going to do? You're going to mark the first element. It's a straightforward technique. Here you can see type A array n, which is a maximum, which is the minimum. You're going to find out max and you're going to mark max and min as the first element. Next, from second element you go on doing the comparison. If a of I greater than max, then that will be max. If a of I is less than min, that will be min. So you go on comparing. Okay. Now, what you need? You need a 2n minus 1 number of comparison for the best case, average, and the worst case. So here, what you're going to do? You are just comparing, right? Here, you are just comparing. Now, what you're going to do? By realizing the comparison is false, okay, improvement of the algorithm can be done. Hence, we can replace the content of the for loop by instead of for loop. So, the content of the for loop will be included with this type of statement. If a of I greater than max, then maximum will be a of I. Else, if a of I is less than min, minimum will be a of I. On the average, a of I is greater than max half of the time. So, average number of comparison is 3 into n by 2 minus 1. Next, algorithm based divide and conquer strategy. Now, this is applying the divide and conquer technique in solving this particular problem. Okay, so void max min I and j, that is minimum, that is the minimum index and the maximum index, followed by maximum number of elements within this particular index and minimum number of elements within this particular index. Now, what is this? This is an array, global array, where you have a parameters I and j, okay, where 1 less than or equal to I, less than or equal to 1, less than or equal to j, less than or equal to n. Okay, now if I equals j, what if there is only one element? Then that element will be the maximum element, that element will be the minimum element. Else, if there are two elements, okay, if there are two elements, then you're going to compare this a of I with a of j. Okay, a of I is a of j. If a of I is smaller than a of j will be max, this will be min. Else, a of I will be max, a of j will be minimum. Okay, next, what if there are some hundreds? Okay, what if there are hundreds of elements? If there are hundreds of elements, then you're going to find out the minimum. Mid equals I plus j by 2. Then you're going to apply the recursive mid sort onto the left hand side, and you're going to apply the recursive mid finding out the max min on the right hand side, and then you're going to combine the solution. That is, if max is less than max 1, max will be max 1. If minimum is greater than minimum 1, minimum will be minimum 1. Okay, now suppose we simulate a max min on the 9 element 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so according to this particular algorithm, max min I, j, max and min. Now, what is the value of I? The value of I is 1. What is the value of max? 9. In this, which is maximum 60, which is minimum minus 80. Now, on dividing this, okay, on dividing this, what is on dividing this? It is 1 plus 9 by 2, I plus j by 2. What you are going to get? 5. Okay, so 1 to 5 on the left hand side, 6 to 9 on the right hand side. Now, from 6 to 9, which is the maximum, which is the minimum? Maximum is 60, minimum is 17. On to the left hand side, which is the maximum, which is the minimum. So 22 is the maximum, minus 8 is the minimum. Okay, but still we are not yet done here. Again, you divide that. Okay, it is 1 plus 5 by 2, 3. So 3 will be the minimum. 3 will be the mid. So 1 to 3. So 1 to 3. which is the minimum, which is the maximum, 22 and minus 5. And on the right hand side, you just find only 4 and 5. So 4 and 5, okay. So now minus 8 is the minimum, 15 is the maximum. Okay, so further you can't divide it. Next, what you're going to do, onto the left hand side, it is 1 2 22 3 on the onto the left hand side. Again 1 plus 3 1 3 1 plus 3 by 2, that the value you're going to get is 4, you're going to get is 4 by 2. 4 by 2 is 2. So on the left hand side, 1 to 2. So 1 to 2 here, which is the minimum, which is the maximum, 22 is the maximum, 13 is the minimum. And then here onto the right hand side, here you have 3 and 3, minus 5 and minus 5. Next, what you're going to do, further can you divide this? No. Further can you divide this? No. So what you're going to do, you go on combining, and from that you're going to get the minimum. Okay, now what is the analysis? Okay, now what is the analysis? Now the analysis here is, what is the number of element comparison? That is, you're going to do it for the left hand side, you're going to do it for the right hand side, and then you're going to do the comparison. Next, what if the number of elements is 2, the time taken is 1. If the number of elements is 1, time taken is 0. Now when n is the power of 2, okay, what you're going to do, n equals 2 power k. Now using the substitution method, okay, using substitution method, you're going to get 2 square t of n by 2 square plus 2 square plus 2. Okay, it goes on, and then it will be 2 power k minus 1 t of 2 plus this whole we are going to consider it as 2 power I. Okay, now substituting that, 2 power k minus 1 plus 2 power k minus 2, the value what you're going to get is 3 into n minus 2 minus 2. So compared to straightforward technique, okay, here divide and conquer saves 25% of the comparison. Okay students, thank you.